Okay, how you guys doing there? Hopefully you're doing well, keeping up on your stuff. We're about ready to start section 3-5. This section, I don't know, some of these problems are going to take a little bit of work, but I don't think it's too difficult as long as you follow along. We're going to basically do the same problem over and over and over, just with different numbers in it, so that's the good news. Might get a little boring though because it seems like doing the same thing over and over and over. Now, I will say this. If you're sitting there going, gosh, I'm glad we're done with those sections. I'm tired of factoring and using the quadratic formula and stuff like that. Well, guess again, okay? I've already told you guys that factoring is something you've got to, when you get out of this class, Algebra 2, you've got to know how to factor, okay? We're going to keep factoring off and on again from, for the next few months, okay? It'll pop up from time to time, okay? So you still got to be able to factor, and we're going to be factoring a lot today, okay? So anyhow, we're going to start section 3-5, and I'm not going to give any notes today. We're just going to actually dive into the assignment. This assignment, we're starting Thursday, today, on December 3rd, and it's due next Tuesday, December 8th, okay? So December 8th is next Tuesday. That's when this assignment is due. So anyhow, let's dive into this. Section 3-5, there's like about 28 questions. You want to get on this assignment because these problems, they're not ones you can just look at and say, oh, the answer is this. It's going to take a little bit of work, okay? So anyhow, we're going to dive in on exercise number 3. Let me move this so we can see a little better. There we go. Okay, so question number 3. Hang on a second here. They ask us to solve some systems of nonlinear equations. If you remember, back in chapter 1, we solved systems of linear equations with the substitution and elimination methods. Remember those 3 equations with 3 unknowns, x, y, and z, and you had to, times an equation by a number and add it to the second equation and stuff like that. Those ones that took up like half a page of paper. Well, we're doing solving systems, but they're going to be non-linear. They're not going to be lines, okay? So it might be a line and a parabola or 2 parabolas, and it's where they touch, okay? If you were to graph them, we're not going to graph them, okay? We're going to do it algebraically, okay? So anyhow, we look at section, was this 3-6? 3-5. 3-5 number 5 we're starting on, and number 3. Number 3 we're starting on. They give us y equals x plus 2, and then y equals, what? 0.5 x plus 2 squared. 0.5 x plus 2 squared. So if we graph this, that'd be a line and that'd be a parabola, okay? So we want to find out the solution, okay? So where they touch. So if I give you a parabola, say this is the parabola and here's the line, the solution would be here and here, okay? Well, I got to find out where those points are. Well, if y equals this and y equals that, then this equals that. So I'm going to write this equals that. X plus 2 has to equal 0.5 x plus 2 squared, okay? Now, we're going to simplify this. Now, first off, I don't like fractions or decimals, okay? 0.5 is the same as a half. I'm going to double each side. That'll get rid of this decimal. If I double 0.5, it turns into a 1, okay? So double this side and double this side. So we have 2x plus 4 equals 2 times 0.5 is 1, so that's gone. 1 x plus 2 squared, okay? All right, so next thing we're going to do is we're going to FOIL this thing out, x plus 2 squared. What you don't do, a lot of students will say, well, you just square x and you square 2. That doesn't work, okay? When you square x plus 2, you have to do all of x plus 2 times all of x plus 2. Is 2x plus 4. We FOIL this out. Our first terms are x times x, which is x squared. My outers are x times 2, that's 2x. My inners are also 2 times x, which is 2x, and 2 times 2 is 4. Equals 2x plus 4. Okay, now, this is, and we can simplify this. Well, I'll tell you what, I can put these two together, but I don't really need to, and I'll show you why. This is a quadratic. Quadratics are supposed to equal 0. Okay, they're supposed to equal 0. So we need to get rid of this side. It doesn't matter which side. I'm going to get rid of the right side, or the left side. So minus 2x, minus 2x, minus 4, minus 4. If we do that, these cancel. We're left with x squared. This 2x minus 2x, those cancel. We're left with plus 2x. And 4 and negative 4, those cancel. Okay? I'm going to factor this. Okay? I'm going to factor this in order to solve. So we have 0 equals, I can factor an x out of this. X times x plus x times 2. Now, so we have this times this, and we get 0 for an answer. So either this is 0 or this is 0. What makes this 0? Negative 2. What makes this 0? 0. So x is 0 as well as negative 2. Now we're not done. Okay? We're looking for the points where these lines, or this line and this parabola touch. A point is an x value and a y value. We have x values of 0 and negative 2. we need to find the y values, okay? So how do I do that? We plug in 0 and -2 into either one of these. It doesn't matter, okay? I'm going to use the top one. It's easier. If I plug in 0 here, 0 plus 2 is 2, so y is 2. So when I plug in 0 for x, I get 2 for an answer. Then I'm going to plug in -2, and again, I could plug in either one. It doesn't matter. If I plug in -2 here, -2 plus 2 is 0. So when I plug in -2, I get 0 for an answer. So the parabola and the line touch at the point 0, 2, and -2, 0. Now, if you're a little bit struggling on this, I would stop and rewind this and watch it again, okay? But the next problem, they're going to be similar. These are going to be similar type questions, okay? We look at question number 5. Okay, number 5. So we have y equals 1/3 x plus 2. And y equals -3, -4, -5. Y equals -3x squared, -4x minus 5. I think that's what it says, -3, nope, -5. Make sure you write it down right. -5, -4. -3, -5, -4. Okay, so if y equals this and y equals that, this equals that. So 1/3 x plus 2 equals -3x squared minus 5x minus 4. Again, I don't like decimals or fractions. I have a fraction here. I'm going to multiply everything by 3. Times everything by 3. So these 3's are going to cancel, and left with 1x plus 3 times 2 is 6 equals 3 times -3 is -9x squared. 3 times -5 is -15x, and 3 times -4 is -12. Again, this is a quadratic. It has to equal 0. I'm going to make this side equal 0 this time. It doesn't matter which side equals 0. It really doesn't, okay? So I'm going to add 9x squared, add 9x squared, add 15x, add 15x, add 12, add 12. If I do that, the whole right side turns into 0. The left side we have 9x squared. X and 15x is 16x plus 6 and 12 is 18. Okay? So we could either factor this thing or we could use the quadratic formula. Okay? We could use the quadratic formula. I'll tell you what, this doesn't look like an easy one to factor. So I'm going to use a quadratic formula. So A, B, and C. Okay? Let's see. So we have -b, -16, plus or minus the square root of b squared. 16 squared is 256, minus 4. A times c is 9 times 18, which is 90, 162, over 2a. 2 times 9 is 18. If we simplify this, we times first. 256 minus 4 times 162 is 648, I believe. 648 over 18. And then -16 plus or minus. 256 minus 648 is negative, what is that? 192, I think? No, not that. 392 over 18. Is that what it is? 392, 640. Yes, it is. Now, here's the deal. I don't like this question. And what I mean is this. I don't like the way the question is phrased. It says, solve the system, select the solutions, okay? Well, at this point, based on our last section, you should understand that the solutions are imaginary. Inside the radical, which remember we call the discriminant, it's negative. So there are two imaginary solutions. So there are solutions, okay? So this is a poorly worded question. What it means is this. There are solutions. But you know what the correct answer here is? No solution. They're imaginary solutions. What they should say is this. Where do the graphs of these touch? They don't. They do not touch, okay? So the answer is they don't touch, okay? So for this one, though, there are solutions. Again, you really shouldn't say there's no solution. There are solutions. They're imaginary, though. They don't touch. So in order to get the right answer, put down no solution. Even though there are solutions, there are no places where the parabola and the line touch, okay? So again, I'm getting, I guess, picky here, but I mean, we just spent an entire section talking about imaginary solutions, and now they're saying, oh, those don't exist. Yes, they do, okay? So again, what the book should have said was, where do these two graphs touch? And the answer is, they don't. So put no solution, okay? No, there's no real solution, okay? Number 7. What's this one say? Y equals x squared plus 8x plus 18. Y equals x squared plus 8x plus 18, and y equals negative 2, negative 16, negative 30. Negative 2x squared, negative 16x, negative 30. Negative 2, negative 16, negative 30. Negative 2. Okay, so if y is this and y is that, and this is that. So x squared plus 8x plus 18 has to equal negative 2x squared, negative 16x, negative 30. We just set these equal to each other. One side needs to be 0 because it's a quadratic. I want to make this side 0, so add 2x squared, add 2x squared. Add 16x, add 16x. Add 30, add 30. So this side's going to all go away to 0. 1x squared and 2x squared is 3x squareds. 8 and 16 is 24x's. 18 and 30 is 48. Okay, so that was a mess. It's looking a little better now. I could factor out 3 out of all of this. 3 times x squared plus 3, and I can't factor an x out though because that has no x. 3 times 8x, 3 times 16 is 0. Okay, this does factor, okay? And I see this, 16 and 8, numbers that pop in my head are 4 and 4. 4 times 4 is 16, 4 plus 4 is 8. So x plus 4, x plus 4. Okay? Because 4 times 4 is 16, 4 plus 4 is 8. So my solutions are x is negative 4 and negative 4, but we don't need to write it twice, okay? We're not done though. We still have to find out what y is, okay? So I plug in negative 4 into either one of these, it doesn't matter, I'm going to use the top one. So y equals negative 4 squared plus 8 times negative 4 plus 18. Negative 4 squared is 16, 8 times negative 4 is negative 32 plus 18. 16 minus 32 is negative 16, negative 16 plus 18 is 2. So the answer is negative 4, 2. That's where these are two parabolas this time, a parabola and a parabola. They touch at the point negative 4, 2. Okay, let's look at number 9. Question number 9. Okay. This is not a racing day. I'm using a rag that's seen its better days. Number 9. Okay, so we have y equals x minus 2 squared. And y equals negative and 4 minus 2. Negative plus 4 minus 2. Yep, okay. So y is this and y is that. This is that. So x minus 2 squared has to equal negative x squared plus 4x. Take away 2. Okay, x minus 2 squared means x minus 2 times x minus 2. I'm going to FOIL this thing out. When you square something, you times it by itself. We FOIL this out. X times x is x squared. I'm going to skip a step here. My outers are negative 2 times x, and my inners are also negative 2 times x, and negative 2x and negative 2x is negative 4x. Negative 2 times negative 2 is a positive 4. Okay. I have to make one side 0. I'm going to make this side 0, so I'm going to add x squared, add x squared. I'm going to minus 4x, I'm going to minus 4x. I'm going to add 2, I'm going to add 2. The right side turns to 0. X squared and x squared is 2x squareds. Negative 4x and negative 4x is negative 8x. 4 and 2 is 6. I can factor out a 2 out of all of this, okay? So 2 times x squared minus 2 times 4x plus 2 times 3 equals 0. And this factors further. X squared is x and x. Last term's positive, so it's either plus plus or minus minus. Got to come up with some negatives somehow. There's only one way to multiply and make 3, 1 and 3, and that works because they add up to 4. So, what makes 0? 1 and 3. Now, in order to find the y values, we plug in 1 and 3 into either one of these. It doesn't matter which one. I'm going to use the top one. The top one looks easier to me. I'm not going to show my steps on this. If I plug in 1 for x, 1 minus 2 is negative 1. Negative 1 squared is 1. Plug in 3 for x. 3 minus 2 is 1. 1 squared is 1. So my answers are 1, 1 and 3, 1. So if I graph those two parabolas would touch at the point 1, 1 and 3, 1. Okay, number 11, okay? They give you graphs here, okay? I'm not going to put the graph up on the board here, okay? If you look at it, they give you two parabolas. They want the solution. The solution is simply the point where they touch. Okay, so I mean, when you're looking at it, number 11, if you look at it, it's very obvious that they're touching at one point, and it's the point -4, 1. I mean, that's all they want to make sure you understand, is that the solution is where they touch. Okay. Same with number 13. They give you a couple of parabolas. These actually touch in two places, okay? And when you look at it, it's very obvious that they touch at the point 1, 4 and 9, 4, okay? There's no work to show on those, okay? They just want to make sure you understand the solution is where they touch. Okay, got done with the easy ones. Let's do some tougher one again. Number 15. Okay, so we have y equals x plus 5 and y equals x squared minus x plus 2. Y equals x squared minus x plus 2, I think it said. Minus x plus 2. Okay, so again, if y equals this and y equals that, this equals that. So x plus 5 has to equal x squared minus x plus 2. I'm going to make one side 0. I'm going to make this side 0. And again, it doesn't matter which side you make 0. It doesn't matter, okay? I'm going to get this 0. So minus x, minus 5, minus 5. Do that. These cancel. 0's on the right or on the left. We're left with x squared, a negative x and a negative x, a negative 2x. 2 and negative 5 is negative 3. So this does factor. Okay? X squared is x and x. Don't do this. Don't do this. I see students see minus, minus, and think, oh, you put minus, minus. That's not the way you do that. You don't do that, okay? We've told you that you look at your first term, then you look at your last term. To make a negative, there's two ways. There's only one way to make a negative. A positive and a negative, or a negative and a positive. Okay, it doesn't matter, okay? So I'm going to put plus, minus. It doesn't matter if I put plus, minus, or minus, plus. Don't put negative, negative. A negative times negative is a positive, and that's not a positive, it's a negative. And then how do you times to get 3, but add to get 2? But one of them has to be negative. There's only one way to times to get 3. But one of them has to be negative, and they add up to negative 2, so it's going to be a positive 1 and a negative 3. Because those add to negative 2. So what makes 0 here? Negative 1 and positive 3. And then we got to find out what our y values are. So we plug in negative 1 and 3 for x on either one of these. The first one looks easier. Plug in negative 1 for x. Negative 1 plus 5 is 4. Plug in 3 for x. 3 plus 5 is 8. So negative 1, 4, and 3, 8 is the solution. Okay? I believe that every one of these that I picked in your assignment is factorable. Okay? So, which means you should get nice answers. Okay? Can you use a quadratic formula? Yes, you can. But I'm telling you right now, I'm almost positive that every one of these can be factored, okay? So you don't need to worry about the quadratic formula. So x squared plus y squared is 64. This one's an easier one. X squared plus y squared is 64. And y equals negative 8. Okay, this is an easy one. Now, this is a line. This is a horizontal line, y equals negative 8. And this right here is not a parabola. When both of them are squared, that's actually a circle, okay? So you have a circle in a line, okay? So we got to find out where this line, and if you have a circle in a line, you could have two solutions here and here, or maybe, oops, they're supposed to touch, one solution there, right there, or it might have 0. Here's a circle, here's a line, they don't touch, okay? So you could have a circle and a line, you could have one solution, two solutions, or no solutions. So we know that y is negative 8, so we just got to find x. So plug in negative 8 here. So x squared plus negative 8 squared is 64. X squared plus negative 8 squared is 64. Now, we could factor this, but we don't need to. We could use square roots because there's only one x. Minus 64, minus 64. X squared equals, those cancel, and so do those. Square root, x is 0. So the answer is 0, negative 8. That was an easy one. Number 19. Okay, this one's going to be a little tougher. Okay, 2x squared plus 4x minus y, 2x squared minus y is negative 3, and 2x plus y, 2x plus y equals negative 4. Ooh, let's make it, no, it's negative 2x plus y. That's, make a big mistake there if I didn't do that. Okay, now they tell you to use substitution here. You use substitution when you either know what x is or you know what y is. Back here we knew what y was. Over here we knew what y was. Y was this and y was also that. Neither one of these tell you what x is or what y is, but it wouldn't be that hard to solve for either x or y in one of the equations. This one right here, it'd be simple to solve for y, you just have to get rid of the negative 2x. So if I add 2x and I add 2x, y is 2x minus 4. So what I'm going to do is, I'm going to rewrite this equation, but where I see a y, I'm going to plug in 2x minus 4. So, and when you plug stuff in, put it in parentheses, okay? Always put it in parentheses. So, 2x squared plus 4x minus, oh, there's a y, put in parentheses, 2x minus 4 equals negative 3. I just rewrote the top equation, but when I got to the y, I plugged in what y was. Distribute the negative sign. Okay, so we have 2x squared plus 4x, negative 2x, positive 4 is negative 3. Okay, we're going to do a couple of things here. It's a quadratic, so it's got to equal 0. I'm also going to put these like terms together. So if I do that, I have 2x squared, 4 minus 2 is 2x, 4 and 3 is 7, equals 0. Okay, so this one, okay, we could try to factor this one, okay? You might be thinking, well, why, try to factor. You just said everything factors. You don't need the quadratic formula. This would be a tougher one to factor, okay? And I need to amend what I said just a few minutes ago, okay? I'm going to use the quadratic formula, okay? So negative b, we have a, we have b, we have c. Negative b is negative 2 plus or minus the square root of b squared. 2 squared is 4. Minus 4 times a times c. 2 times 7 is 14 over 2a. 2 times 2 is 4. Now, here's the deal, okay? I'm not going to show any more work on this. 4 times 14 is 56. You know what 4 minus 56 is? A negative number. The square root of a negative is imaginary, okay? There are two imaginary solutions, so where do they touch? They don't. There's no solution. So I said a minute ago, I need to amend what I said earlier. Here's the deal. It either factors or there is no solution. The ones that I picked are either factor or there is no solution, okay? So, all right, next one. That was number 19. Okay, number 21. What does this go to? Not too many more. 21. So we have y equals x squared minus 1. And what? Negative 7 equals negative x squared plus what? Negative x squared minus y. X squared. Okay. So we know what y is. Y is x squared minus 1. So I'm going to plug in x squared minus 1 for y into the second equation. So negative 7 equals negative x squared minus parentheses x squared minus 1. Okay? Let's distribute the negative sign. Negative times x squared is negative x squared. Negative 1 is positive 1. I can put together a negative x squared and a negative x squared, which is a negative 2x squared plus 1. In this one, I can actually use square roots. I don't need to factor this one. I could use square roots on this one because there's only one x. So I'm going to minus 1. Negative 8 equals negative 2x squared. Divide negative 2, divide negative 2, we get positive 4 equals x squared. And then we square root. And be careful here, okay? I know I've told you this, but it's still something students forget a lot. Students go, oh, radical 4, that's 2. You're half right. Whenever you add there was no radical in this problem until this point. I added the radical in. When you add a radical in, you have to put a plus or minus symbol there. So x equals plus or minus radical 4, which is plus or minus 2, okay? I'm actually going to write x can equal 2 or negative 2. We still have to find y though, okay? So I'm going to plug in into the top equation. If I plug in 2, 2 squared is 4, minus 1 is 3. Plug in negative 2. Negative 2 squared is 4, minus 3. Or minus 1 is 3. So we have 2, 3, and negative 2, 3. Those are our two answers, 2, 3, and negative 2, 3. All right, number 23. 23. Okay, 23. So we have x squared plus y squared is 7. Again, we have a circle. And x plus 3y is 21. And a line, a circle and a line, okay? Again, we're going to use substitution. Neither one of these say what x is or what y is, but it wouldn't be that hard to solve this one for x. Just get rid of the 3y. So subtract 3y. X equals negative 3y plus 21. So I'm going to rewrite this, but where I see an x, I'm going to plug in negative 3y plus 21 and put it in parentheses. So in parentheses, negative 3y plus 21 squared plus y squared is 7. This squared means this times itself. If we FOIL this out, negative 3y times negative 3y is 9y squared, positive 9y squared. My outers, negative 3y times 21 is negative 63y. My inners are also negative 63y. My last, 21 times 21 is 441, plus y squared equals 7. Okay, we can do several things here. It's quadratic, supposed to equal 0. So minus 7 and minus 7. I have to put together 9y squared and y squared, and also negative 63y and negative 63y. Y squared and 9y squared is 10y squareds. Negative 63 and negative 63 is negative 126y. Plus 441 minus 7 is 434 equals 0. Okay, so that one looks better. All right, so, and I tell you what, we're going to fudge this one a little right here. This one doesn't factor, which means you need the quadratic formula. So in this case, there's going to be no solution. If I use the quadratic formula, you're going to get no solution on this, okay? And again, there are solutions, they're just imaginary. What we mean is the two circle and the line don't touch. They don't touch. There's no solution. And it'll be the same way on the test, okay? They either are going to factor, or if they don't factor, there's going to be no solution, okay? All right, 23 on to number 20. Skip 24 on to number 27. There is no 25 or 26, so we're on number 27. We're getting close to being done with this section. I think we only have, what, 27, 29, 30, let's see, 27, was that 27? 27, 29, 33. 3 more to go. Okay. 27, so we have 2x squared minus 3x. 3x minus y is negative 5. And negative x plus y is 5. Negative x plus y is 5. Okay, so again, we're going to use substitution. Neither one of these say what x or y equals. I'm going to solve this one for y. I'm going to add x and add x. So y equals 5 plus x, or x plus 5. So I'm going to rewrite this. Well, I'm going to plug in x plus 5 in for y, but put it in parentheses in the first equation. So we have 2x squared minus 3x minus parentheses x plus 5 equals negative 5. Distribute the negative sign. So we have 2x squared minus 3x minus x minus 5 is negative 5. We're going to do a couple of things here. It's a quadratic. It's supposed to equal 0. So add 5. I'm also going to put these two things together. So if we do that, we have 0 on the right. We have 2x squared. Negative 3 minus 1 more is negative 4x. Negative 5 and 5, those cancel. So I can actually, I don't need a big gap here, but that's all right. I can actually factor this. I can actually factor a 2x out. 2x times x, 2x times 2. So what makes this 0? 2. What makes this 0? 2 times what gives you 0? 0. Okay? If I plug in 2 here, 2 minus 2 is 0. If I plug in 0 here, 2 times 0 is 0. So x is 0 and 2. We still have to find our y values. I'm going to use this equation right here. If x is 0, y is 0 plus 5. If x is 2, y equals 2 plus 5. So the answers are 0, 5, and 2, 7. Okay? 2 more to go. Okay. 29. Okay, they say solve with elimination. Well, we haven't used elimination yet. We've used substitution every time. We can do that. We can actually use elimination here. So we have negative 3x squared plus y equals negative 18x plus 29. And then the second one has negative 3x squared minus y equals 18x minus 25. This actually is going to be really nice with elimination. We haven't talked about this at all yet today, but we did it back in September. We want to use elimination because if I add these up, these y's are going to cancel. Okay? Now be careful, these are not going to cancel. Some students think these will cancel. Okay? These will cancel, but negative 3 and negative 3, those actually add up to negative 6x squared. Those add up to nothing. Those add up to 0. Those add up to 4. Okay? So, then we need to divide by negative 6, divide by negative 6, x squared equals 4 over negative 6. Now, this is a nice one actually. We square root it. What's the square root of a negative number? Imaginary. There's no solution to this. Again, there are solutions that are imaginary. Click on no solution on the computer, that's what it wants you to click on. But there actually are two solutions, they're imaginary. And it's just that where these two graphs touch, they don't touch. These two graphs do not touch. Okay, 33. There is no, let's see, we did 29, then 30s for you guys. There is no 31 or 32. 33, last one. Last one of this assignment that I'm going to do with you guys. Okay, it says by elimination, we're going to use substitution. Because this is y equals negative 3x squared. And I will tell you this. We did exactly one problem in this assignment that was with elimination, and it came out as no solution. So you can probably guess how many problems on your test are going to be using elimination. None of them, okay? So, negative 30x, negative 76. Negative 3, negative 30, negative 76. 2, 20, 44. 2x squared plus 20x plus 44. 2, 20, 44. Is that what I said? Yes, it is. Okay. If y equals this and y equals that, this equals that. So, negative 3x squared minus 30x minus 76 has to equal 2x squared plus 20x plus 44. Again, a quadratic has to equal 0. I want to make this side 0, so I'm going to add 3x squared, add 3x squared. I'm going to add 30x, I'm going to add 30x. I'm going to add 76, I'm going to add 76. If I do that, the left side 0, 3 and 2 is 5x squared. 20 and 30 is 50x. 44 and 76 is 120. Okay, I'm going to move this up here. So, we have 0 equals 5x squared plus 50x plus 120. Okay, I can factor a 5 out of all that. Not an x, because that has no x on it. So 5 times x squared plus 5 times 10x plus 5 times 24 is 120. This factors, okay? When I look at 24 and 10, two numbers are popping into my head, 4 and 6. What's so special about 4 and 6? Times 24, add 10. So 5x and x. No negatives anywhere, so plus plus, 4 and 6. What makes 0? Negative 4. And negative 6, okay? To find the y values, we plug in negative 4 into either one of these equations, it doesn't matter. I'm going to use the bottom one. So 2 times negative 4 squared plus 20 times negative 4 plus 44. I just used this one. I think it looks a little easier than that one. We plugged in negative 4 for each of these x's. Negative 4 squared is 16 times 2 is 32. 20 times negative 4 is negative 80. Plus 44, 32 minus 80 is negative 48, plus 44 is negative 4. Then we're going to plug in negative 6. So 2 times negative 6 squared, plus 20 times negative 6, plus 44. Negative 6 squared is 36 times 2 is 72. 20 times negative 6 is negative 120, plus 44. 72 minus 120 is negative 48. Plus 44, negative 48, 44 is negative 4. So negative 4, and 6, negative 4. Hopefully that's right. negative 4, 6, negative 6, negative 4. Yes, that's it. Okay, so don't fall behind on this section. This is going to take a little bit of time, okay? So anyhow, this assignment is due next Tuesday on December 8th. If you have questions, email me and I'll get back with you as soon as I can, okay? We'll talk to you guys later.